Welcome to BDB Decision Platform version 3.5. Today we will be exploring the predictive workbench of our platform. The predictive workbench has different environments like R, Spark, Python, and Java. So we will be exploring the R workspace foremost. This is the R workbench console where there are a lot of options to perform different sort of operations over the data. The first one is saved workflow. So it has all the list of previously saved workflows inside it. Then there is a data source option. This whole UI is drag and drop based UI. So you can drag and drop the components like this. As for data source, you can choose the source of your data. And for CSV component, you can browse the CSV file from your system and so on. For data service component, you can drag and drop the component, and that can be used to fetch the data from existing data connector. You can choose the data connector from here and the data service from here. That will fetch the data service from data center. Another option is data preparation. So in data preparation, you can perform ETL over your data. It has provided with the different components like data type definition to change the data type of your data, to filter the data, whether it be row-wise or column-wise, for missing value replacement, to apply some formula over the data, for normalization, for sampling, and there is a component called R-split data for training and testing purpose. Going forward, in the algorithms, we have numerous supervised and unsupervised algorithms. So we have R-k-means clustering component. In forecasting, we have triple exponential, single exponential, double exponential, R-ARIMA, R-auto forecasting. Then we have market basket analysis in association. Then we have R linear, R multiple linear, and R logistic regression in regression analysis. Interquartile range outlier algorithm, R CNR tree, and R naive Bayes classification algorithm. And there is R correlation component as well. Then there is an apply model component. This R apply model can be used to apply a model on test data set plus save a model. The save model can be found in saved R models and later can be used as a component inside any workflow. Then there is a performance component as R performance to compare the performance matrix of the different models such as accuracy or confusion metrics, ROC curve, etc. Then there is a data writer component to write your data back to data store or any database or a file. In file writer, we have CSV and JSON writer. Similarly, we have internal data writer and Cassandra writer in database writer. Now we have customer R script component to create a new script. Through this, you can create your own R script. You can give the component name and write your script here. Once you write your script, save it. It can be found in the saved scripts, and those scripts can be used as a component later in the workflow. Next is scheduler. To schedule a workflow, so in this you can name a workflow which is to be scheduled. Give a job name to it to monitor the scheduling. And then accordingly you can make changes in the data store and the data writer. So for example, if we change our data writer here, then we can make changes in that. Let's suppose we take this. And then comes the scheduling part where you can schedule, put your start date, your end date, schedule it hour-wise, daily, weekly, monthly, yearly. And there is a notification enabling option where you can get and receive email notifications of your scheduled workflow. You can monitor the status of the workflow through this tab, where you can view the logs, perform some actions on ongoing scheduling like edit, start, stop, or remove. The last one is saved R models, where there are previously saved R models that can be used as a component inside any workflow. Now we'll be having a look at Spark environment. So this is a Spark workbench. We have similar options to perform the operations on our data. Like there is saved workflows where we can find the previously saved workflows. Then there is a data source component in which we have a Cassandra reader. We can do the similar kind of configurations with that to put it as a source of the data. Then there is a data preparation feature which has Spark split data component to split the data for training and testing purpose. The second is Spark filter for filtering of the data. Then there is Spark data type definition to change the data type. So we have a data transformation feature where we have multiple components. The first one is Spark string indexer. So this will index the string value to the numerical value. Next we have Spark R formula to write a formula to perform transformation over the data. Then we have two components named as Spark PCA and Spark chi-square for dimensionality reduction. Then again we have Spark index to string. It will index the numerical value back to string value. Then there is a Spark SQL transformer. If we wish to write this query into SQL, we can use this component. Then there is a Spark group by for grouping purpose to group the data column-wise. Then we have algorithms, which contains Spark k-means clustering component. For classification, we have Spark naive Bayes, Spark decision tree, and Spark random forest components. Then we have recommendation engine as Spark ALS component. These are all the algorithms available inside the workbench. Then there is an apply model as Spark apply model component. This component can be used to apply a model on the test data, and plus a model can also be saved, which can be found here and later can be used as a component inside another workflow. Then we have performance component as Spark performance component to track the various performance metrics of a model. such as accuracy, confusion, ROC curve as mentioned like in our workbench. Then there is a data writer to write the data back into a database. Then there is an option for custom Scala script. So you can write your own script in Scala, which is based on Spark ML. So for this, component name can be given and the script can be written here. Once it is validated and saved, it can be found inside the saved scripts and later can be used as a component in the workflow. Then we have live job status. So in that, if there are multiple workflows running inside this workbench, then the live real-time status of those workflows can be monitored from here. We can view the logs, the summary, we can perform some actions over it. And then there is a list of saved Spark models that we have created and are ready to be used as components inside another workflows. Now we will be having a look at Python environment. So this is the Python workbench. We have the similar options. This one is saved workflows for all the previously saved Python workflows. Then we have data source in this one as CSV file, data service, data store reader. Then we have data preparation in which we have missing value replacement component, normalization Python component, and Python split data component. Then we have algorithms inside it, that is the regression analysis algorithms. For this we have Python linear regression, Python multiple linear regression, and Python logistic regression analysis components. We have apply model component. So the Python apply model component can be used to apply a model on the test data again and can be saved also to further use it as a component inside another workflow. That saved model would be found in the saved Python models. Then we have data writer to write our data back into a data store or a file writer, which can be in JSON or CSV format. Then we have a database writer component for internal data writer. Again, we have custom Python script, a feature where we can write a new script in Python. We would be naming the component and writing the script here. Once we save it, it can be found here and can be dragged and dropped easily. There is a scheduler as well in the Python workbench for scheduling the Python workflow. We can choose any workflow, give a demo name, a job name to it, modify the data source and the data writer, and then go to scheduling part. We can choose the data connector and the data service. We can also see the status of the scheduled workflow. View the logs, perform actions over it. And then there is saved Python models, which has previously saved models ready to be used as the components inside the workflows. Let's now have a look at one of the sample workflows. So we can open one of the workflows with various components. So there are icons to perform various sort of operations on this workflow. This is to run. To refresh the workflow, we have this icon. To reset, to clear the cache, to save or save as, for parallel processing, to assign multiple cores to a workflow. Then there is a back icon and a full screen mode icon. As we ran the workflow, we can see the real-time execution of that workflow under the console tab. It can be viewed completely, all the algorithms in action. So then going forward component wise, we can select one component and have basic properties of that component as component name, description. Then there is a property tab for it. So you can see the data service properties and fields under it. For that particular component, we can view the summary of that component, summary of that data. We can see the result of that particular component like this. If we go to another component, there is a similar general properties and advanced tab. Then we can again have a look at the summary of it and the result of that component. Here, if we select this algorithm component, we have feature for the validation of that component. So you can select any validation method from here and the summary of the model and the very beautiful visualization of that model in a full screen mode. In the end, we can see that you can choose the performance type as well. It can be chosen as multi-classification metrics or binary classification metrics. Again, we can have a look at the visualization. So it's a very clear ROC curve that we can have a look at.